The next few videos are going to pertain to these notes, methods 1, and then these notes, methods 2. Methods 1 is principally stuff from chapter 6 of the textbook, and methods 2 combines chapter 7 stuff into it. So we dive into methods in and of themselves in the material covered here. And then we kind of combine methods with arrays, because if you recall, we had explored some Chapter 7 material, which was about arrays. And we'll combine methods and arrays and some other topics as well. So that's going to be what we're going to be covering over the next few videos. So let's start by introducing ourselves to methods. So what's a method? Well, a method, as it says here, is a collection of statements that are grouped together to perform an operation. You've been doing stuff with what's called the main method up till now. And there's two aspects when we think about a method. One is, how do we create it in the first place, which is our method declaration. And our method declaration is made up of two pieces. One piece is what we call the header. And the header includes a modifier, return type, something called a signature, which is composed of its name or identifier, and you've had to deal with identifiers of things, obviously, like variable identifiers and class identifiers and method identifiers. Perhaps you'll include a list of what are called formal parameters, and I'm going to use the word parameter in a couple of contexts. I'll use the term formal parameter, and I'll use the term actual parameter, and sometimes people use the word parameter and argument interchangeably, but I'll be a little more specific about that. I will consider an argument to be an actual parameter, and we'll talk more about that in a bit. And when we are declaring our method, when we're specifying this is public or private or static or whatever, when we're specifying the return type, whatever the return type might be, an integer, a Boolean, some class type, for example, even a string, even an array return type, or maybe it's not returning any value, maybe it's a void. And when we're specifying the name and when we're specifying our formal parameter lists, which are types and identifiers as if these were variable declarations, all of that makes up what's called the method header. And when you look at the documentation, the Java class documentation, the API documentation that I've shown you before, you will often see the header being shown to you in the API. And then there's obviously the method body, and the method body has the code that executes when that method is invoked. And that's stuff that's taking place in between curly braces. And maybe you have to have a return statement if, in fact, you have a return type other than void in your methods. Let me also say this. All methods will have some kind of a return type, either integer or Boolean or whatever. And if they have integer or Boolean or whatever, then they will be returning a value that you can use. In fact, something that would be an expression. There's also methods that have a void, which means they don't return any value. However, when we get into talking about object orientation, there's one kind of method that doesn't have any kind of return type, void or integer or Boolean or anything, and that's the constructor. And you'll recall that I talked a little bit about constructors before, and I will talk a lot more about constructors when I get into object orientation. So there's your method header. Here's your method body. Now, that's when we're declaring our method, when we're specifying what this method is and what it's going to do. Then we use the method. And when we use the method, that's called a method call. And when we call the method, one thing we're going to do is we're going to specify the name of the method. Another thing we're going to do is if this method does have a list of formal parameters, then we're going to pass data. And the actual data are these actual parameters that could be literals or constants or variables or expressions, but some kind of actual data. that matches the type expectations of the formal parameter list. And then perhaps, if this was a method that returns something other than a void, then we'll use that return value somewhere. Maybe we'll assign it into a variable, maybe we'll use it in an expression or something of that nature. So we're going to explore this with an example from the textbook, listing 6.1 of the textbook, called TestMax. And you can see that in the Liang samples. And here we have this class. It has a main method, and you're already familiar with the main method, but it also has this other method called max. And here we see the method, the declaration of the method over here. And here we see when we're calling the method. And when we're calling the method, we are passing arguments. These are actual parameters. And what are the actual parameters? I and j, which are these local variables of the main method. Both of them are integers, and you can see that max expects to take 2 integers. So I is going to wind up being num1 as far as max is concerned, and j is going to wind up being num2 as far as max is concerned, and then max is going to do its thing. So let's break that down in a little more detail. First, let me show you this in NetBeans. So here we are in our NetBeans project here, our Liang 11E samples project. And you can see that I have I've opened up the chapter 6 package, and there's a number of interesting things to look at. Maybe we'll take a look at a few of them later. In fact, we're definitely going to take a look at this one, this overloading one, shortly. But for now, we're focused on TestMax, which, as you can see, has a main method and it has a max method. So we're going to look at what the declaration has in a little more detail, and then we're going to look at what takes place when the call happens. So first, let's look at the anatomy of the method declaration and its call. So here's our method declaration right here. And let's take a look at the pieces. You may or may not have a modifier in a method. In this method, we have what's called a modifier called static. And so far, everything we've dealt with has been static as far as members of a class. We'll talk about non-static members later when we get into object orientation. And we actually did talk a little bit about that in the previous lecture when I looked at the API and distinguished between classes that are intended to be instantiated versus classes that are not, and how classes that are not tend to have everything being static. So in this case, we have this modifier called static. And there's our return type, integer. And given the fact that this is not void, that means that somewhere along the line, something's going to have to be returned. An integer is going to have to be returned. There's the name or identifier. And here's 2 formal parameters. They look a lot like variable declarations. In fact, when we look at what's going on inside the call stack, we'll see they're just like local variables of the method. We call these formal parameters. Formal parameters are a specification of the expectation of what kind of data this method is supposed to receive. And then we have our method body, which can include local variable, some kind of code. And given the fact that this particular method has int as a return type, we actually have to return a value, and that value has to be consistent with an integer data type. And we're seeing here that we're returning this local variable. So that's the declaration. In terms of the method call, here is where we're specifying the name of the method that we're going to invoke. And we're passing these actual parameters. So I'm using the term argument specifically for these, as opposed to for these. The actual parameters is data. The formal parameters is kind of an expectation of what the data is supposed to be. But the actual parameter is actual data. The variable I has some kind of value in it. The variable j has some kind of value in it. And then maybe if this particular method, and in this case it does, returns a value, this guy right here, this whole invocation, winds up being an expression, and we can use that expression. And in this case, what are we doing? We're assigning that expression into a variable called k. So that gives you an idea of the anatomy of the declaration and call of a method. And so next we're going to talk about what happens, the sequence of events that take place when a method is called. So once again, we have our method call and our method declaration. And let's see what's going to take place. So we're about to invoke the method. So here's a statement right here. And this is an assignment statement. And you can see a declaration taking place. Well, once we have the declaration take place, then in order to assign a value into that variable, k, first we have to resolve the expression. And this guy right here is an expression. This call to the method is an expression. Remember, everything that you ever see on the right-hand side of an assignment operator is an expression that's going to give you back data. So in this particular case, our expression is going to be the result of calling this method. So we invoke the method, and the actual parameters that we pass, the order in which they're being passed, they're being received as these formal parameters. So really what's going to wind up happening, as we see, is there's going to be a copy of this value right here that's going to be placed here, and a separate copy that's going to be placed here. This is called pass by value. And Java is strictly what's called a pass by value language. Anytime you make a call to a method, the argument that you pass, a copy of that argument is being received in the formal parameter. And then once we've invoked and passed these arguments and they've been received as num1 and num2, the function body executes. All of this stuff takes place. A variable is created, an if statement takes place, depending on the result of the if statement, an assignment takes place. Ultimately, the result is returned. And when that result is returned, this method is done. It's all said and done. And at that point, it gets received by the invocation, which took place, the call, which took place. And now, this expression has been resolved. We now have a value. And at that point, we can assign that value into this variable, in this case, called k. A couple of things to keep in mind is that, of course, the order in which and the data types of the parameters have to match. So, calling this particular method in print line, passing a string and an integer is fine because that's the order in which they're expected, but you can't do it in reverse. That should be fairly obvious, hopefully. So now that we're really starting to talk about methods, it becomes all the more important to understand what's going on in the frame stack, otherwise known as the call stack or program stack. We explored that a little bit earlier on, but always all we saw in the frame stack was just the main methods frame. But as we'll see, frames are put on the stack when methods are called and are popped off of the stack when methods are terminated. And when we talk about a stack, what are we talking about? A stack is as it says here, a last in, first out data structure. You can visualize a stack just like a stack of plates that you might see at a cafeteria. The bus person is putting a bunch of plates in, and the last plate that gets put on the stack is going to be the first plate that some customer is going to take off the stack. So that's basically the idea of this, and it is a kind of a collection of pieces of elements in sort of the same way that an array is a collection of elements, but it's a different kind of a structure. Stacks are used for a lot of purposes, and one of those purposes of the use of a stack is what the Java virtual machine does to keep and manage the local variables and parameters of a method. So each piece that's put onto the stack is called a frame, and that frame basically contains the values of all of the local variables and all of the formal parameters of that method for the duration that that method is actually active and in execution. So when that method is invoked, a frame is going to be created and put on top of the stack. And that frame will continue as long as that method is in execution. And that method may in turn be calling other methods whose frames are going to be put on top of the stack. And then once the method terminates, that frame is going to be gone, which means those local variables and formal parameters are no longer going to exist. So this has to do with the notion of duration. The duration of a local variable and a formal parameter is only as long as the method executes. As we'll see later, duration, this concept of duration, kind of ties in with the concept of scope, where the scope of a variable has to do with what are the instructions that can use that variable, and the duration of the variable has to do with how long that variable lasts in memory. So it's very important to understand what's going on with this frame stack as a program executes. And that kind of an understanding is going to help you to make better use of the debugging tools of an integrated development environment, an IDE like NetBeans. So let's take a look and see what happens in memory during the processing of this particular application. So this is a class that has a main method. What that means is that this is actually an application, a program that will execute. Not all classes have main methods. In fact, most classes don't. But if a class does have a main method, then this is really intended to be like a program that executes, as opposed to a component that might be plugged into other programs that execute. So the first thing that's going to happen is that main is going to execute. And when that happens, the frame stack is going to contain a frame that contains all of main's local data. And if we were to get to this point where we're about to execute this instruction, we're going to have args, and we're going to have I, and I is going to have a 5 in it, and we're going to have j, and j is going to have a 2 in it. And recall what I said about primitive data types, which do exist in Java, although not in Python. When you have primitive data types, what's in the variable is actual data. Here we have the number 5, and here we have the number 2. And really, if I was going to be really accurate about this, you wouldn't have seen K. If you were to look at the debugger, you wouldn't see K yet because we haven't even executed this statement. But let's just imagine that there is going to be a K, and it's going to have a value in it at some point. So that's what we have in main's frame at this point. Now we're about to make a call to the max method. Now let's see what happens then. So we make the call. That means that control of the execution has gone into this method right here. In main, this statement here is waiting. Let me go back. This statement is waiting until the expression to the right of the assignment operator has been resolved. You can't assign a value into this variable until that expression has been resolved. Well, in order to resolve that expression, this method had to be called. So now this method is called, and in main, we're just sitting here waiting until this gets done. And when the call took place, a copy of what was in I, this 5 right here, was placed in a num1. Num1 is not the same thing as I. It has a copy of what's in I. And similarly, num2 has a copy of what's in j. Then the execution takes place here. Our if statement happens. And you can see that, obviously, Num1 is greater than num2, so the result winds up being a 5, and we're about to return. So now at this point, this value 5 is going to be returned. What does that mean? That means it's going to be sent back to the call that took place right here. That means whatever this expression is going to be resolved, and it's going to wind up being a 5. And then at that point, a 5 goes into this variable k. And so then the print is going to take place. Notice another thing that happened. So we made the call to max. Right before the call to max take place, we only had one frame on the stack. We made the call to max. Now we have 2 frames on the stack. And the top frame is max's frame. Max did its thing. It returned its value, and when it was terminated, the frame was popped off the stack. That's often a term that they use with stacks. You push things onto the stack, and you pop them off of the stack. So the frame was popped off the stack. And now there's no such thing as num1 or num2. There's no such thing as result. Those variables don't even exist anymore. That data doesn't exist anymore. And the beauty of the debugger is you can see this stuff happening as it happens. So here we are. Let me just run it first. And you can see the maximum between 5 and 2 is 5. That's what this print line statement was doing. So I'm going to put a few breakpoints. I'm going to put a breakpoint here. I'm going to put a breakpoint here. So here's a breakpoint right before I make the call. And here's a breakpoint after the return. And then I'll put a few breakpoints here. I'll put a breakpoint here. I'll put a breakpoint here. I guess that's what I'll do. Now let's see what happens when I debug it. And we'll take a look at what is there to look at in memory when I debug it. So I'm going to go ahead and debug. And you can see we're right here. We see the variables. I had these watches that was from other stuff. Let me get rid of this watches here. And notice that I do see the call stack, but let's imagine that you didn't see the call stack. How would you be able to see the call stack? Let me close this window. You can go into Window at the top, the menu at the top in NetBeans, and into debugging, and you have all of these different kinds of windows that you can use, one of which we see is the variables down there already. See variables. We also see breakpoint. So if I go to debugging, and I'll go ahead and choose call stack. And here it is. So we have variables, we have call stack. I think I'd like to see both the call stack and the variables at the same time. So I'm going to click my left button here and just kind of drag this call stack. I'll put it down here instead. See, that's very nice. You can move things around. So I'm going to see my variables, and I'm going to see my call stack. So right now, my call stack has one method on it, the main method. So one frame, I should say. And within that frame, this is what we have. We have args, we have I, we have j. We also have this thing called static, and let's not worry about that. But we have args, which is the formal parameter. We have I, which contains a 5, and we have j, which contains a 2. We don't yet see the k, because it haven't even been declared yet. So let's go ahead and continue. Now, we're at the statement. It's going to declare the variable. It's going to make the call to max. And so as soon as that call takes place, because before I can do the assignment, max has to be resolved. Remember, the expression always has to be resolved before you can assign a value into the variable. So in order to resolve it, max has to be called. So I'm going to go ahead and call it. Go to the next step, and now here we are in max. And if we look at max, we see num1, which has a 5, and we see num2, which has a 5. Now, notice that we have 2 frames on the stack. And we're looking right now in max's frame. I could double-click on main, and I can still see mains frame, but there's one 5 here, and there's a whole other 5 here. 2 separate 5s in 2 separate places in memory. You'll also notice that even though we've declared result, you might think result actually is there already, but in the debugger it's not going to show it until you actually have something assigned into it. So I'll go ahead and hit my continue button, and now result has something in it. There's our 5. And notice we still have 2 frames on the stack. And what's going to happen as soon as this return takes place, then this method terminates. This expression up here has been resolved, and this statement right here will have completed, and we're going to see the k has a value. Let me go ahead and do that. And there we have it. Now we've popped max off the stack. And there it is. K has the value 5 in it. See what you can really get an idea of what's taking place under the hood when you make use of the debugger. And it's very important, I think, in order to understand really what's taking place when you do your coding, to have a feel for what's going on in the call stack, and as we'll see later also, and we've already begun to see, what's also going on in the heap, and we'll certainly be doing a lot more of that over time. Okay, I'd like to continue this by talking a little bit more about these variables and how these variables are located in the frame stack and how these variables are accessible by different instructions within the code. And I think I'd like to focus my attention on this notion of scope. So scope is a variable's visibility, which means what are the statements that can actually use that variable? Local variables and formal parameters of a method have what are called method scope. They can be used inside the method, actually only after they've been declared inside the method. You may have narrower scope than that, often called block scope. So if there's a block of code within an if statement or within a while loop or something like that, and you've declared a variable, that variable will only exist as long as that block of code is executing. I did sort of allude to that in previous lecture. In the parentheses of a control structure like a loop, for example, if you have your loop counter variable I for I equals 0, I less than whatever, I plus plus, that is a little bit longer than the block scope. It lasts as long as that loop is executing. Whereas if it was within a block, that would only be accessible from within the block. The variable declared in the parentheses can be accessible within the block and also within the for loop statement itself. It is possible to have many variables of the same name within your code as long as they're not in what's called the same nesting structure, and I'll show you some examples of that. But you cannot declare variables of the same name within the same nesting structure. So let's take a look at this example. We have our main and we have our max. This is the same example we were looking at before. I, J, K, and args are only accessible within here. If I tried to look at variable I in the max method, if I tried to look at variable J in the max method, I would get a syntax error saying that that's not, basically, it's not recognized within that context. There's no such thing as J in max. And vice versa. num1 and num2, result. Main has no access to num1 and num2 in result. So that tells us that the scope of I, J, and K are mains method block, and the scope of result, num1 and num2, are within max. Method scope in both cases. Here's another example, which is going to give you an idea of method versus block versus loop scope. So here we have an example. We have method 1, method 2, and main. And here main would be calling method 1, and then when method 1 terminates, it would be calling method 2. So let's take a look at the scope of variables. Well, here's a parameter called x and a variable called y, and this x and this y are within the scope of method 1. And of course can't be accessed from main, or for that matter even this x can't be accessed from method 2, although there is another x here. And we can see we have a whole other x and a whole other y. I mean, this x is a double, that x is an int. This y is an int, that y was a double. So these are two completely different pieces of data. Don't get confused because they happen to have the same name. This name is only relevant within here. And this name right here is only relevant within here. Only statements within this method can access this x and this y. That's the scope. And only statements that are within this method can access this x and this y. And also, this x and this y is only going to last as long as this method is in execution. And similarly for this. That's duration. Scope and duration, they kind of go hand in hand. So in both of these cases, we're talking about method scope. Here we see example of loop scope and block scope. So loop scope means that this variable called I, which is declared here in the parentheses, is accessible throughout the entire, all of the iterations of this loop, and including within the block as well, but not outside of the block. I can't have a statement outside of this block that references I. Z has block scope. That means Z can only be accessed from within this block, between this curly brace and that curly brace. It can't even be accessed in here anywhere. If I was trying to put a Z here, I would have an error. And in terms of duration, Z is only going to last as long as one iteration of that loop takes place. Then it's going to disappear. Then the next iteration of this loop, a whole brand new Z is going to appear for that brief second, split second, micro, mini, nanosecond. And then it's going to disappear. And then it's going to come back again, and it's going to disappear. As opposed to I, which is lasting throughout the whole iterations, all the iterations of this loop. So there was a distinction between loop scope and block scope. And we have similarly a whole other I. This I and this I are two completely different I's and two completely different Z's. They're not within the same nesting structure, as you can see. This loop is not nested inside that loop. If this loop was nested inside that loop, we couldn't have another Z declaration. But it's not. Now, supposing I tried to declare a variable Y inside this loop. Well, I couldn't do that because I have a Y here. So the loop is nested inside the body of this method, and Y has been declared in the body of this method, and the loop is part of the body of this method, so I can't have another Y here. It's okay to have the two Z's here. One of these loops isn't nested inside the other, but it's not okay to have the two Y's here. And I would like to discuss now the notion of method overloading. And here you see a definition of this method where we can declare multiple methods within the same class. And these methods can all have the same name. but they would have different formal parameter lists. And as it says here, when you call an overloaded method, the compiler is going to know which version you're calling because of the types and perhaps the number of the actual parameters that you pass. We've actually used overloaded methods before. We see them a lot in the Java API. In fact, let's go and look at the Java documentation and see some examples of that. And if I recall correctly, PrintStream has a few methods called printline. So look at all these print lines. Printline, 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 printline. Same method name, but different parameters. So that's an example right there of overloaded methods. So let's dive into that a little deeper. So we're going to look at one of the examples now from Chapter 6. This example has to do with method overloading. You can see that we have three separate methods called max here. And here we can see it in the in Chapter 6 package of the Liang samples. This particular class is called test method overloading. And here we see three separate declarations of methods called max. And each one of them has different kinds of parameters. One takes two integers, another takes two doubles, and a third takes three doubles. So these are three separate methods, but they all have the same name. But they have different parameter lists. Hence, these are what are called overloaded methods. I'd like to point out a terminology distinction to make here. Later this semester, you're going to hear about method overriding as opposed to method overloading. Those are two very different things, and I don't want you to get them confused. Method overriding will start to become relevant when we talk about class inheritance and polymorphism. Method overloading is something very different, and I'm going to want you to make sure that you keep that distinction in mind. So here you can see, based on the kind of calls that take place, which method is going to be invoked. So here we have a max where we pass two integers. So obviously this is the method that gets invoked. Here we had a max that where we passed two doubles. So this is the method that gets invoked. And here is a max where we call three doubles. And so this is the method that gets invoked. And notice what this method does. This method has two calls to max. And in both cases, you're sending two doubles. So here's a call to max where you're sending two doubles, num1 and num2, which were these two parameters that are being sent. And then when this one resolves, that becomes another double. So this call to max is also calling this max right here, passing two doubles. So it'll be interesting to see how that plays out. So let's say we've started execution of the program. We're in the main method, and the main method, if you have an application somewhere along the line, and the main method is going to be the very first thing that gets invoked. So when the main method gets invoked, whatever it has as local data gets placed in its frame. And here we don't have any local variables, as you can see, being declared. We just have this args, and that's all we have here. So let's say we get to the system.out.println. We're about to call system.out.println. When we call system.out.println, well, and what we're going to have to pass is some data for it. Well, in order for that data to be resolved, we needed to call this max method. So here we are at this point about to call the max method, the method that takes two integers, which is this one right here. And we make the call. And what did we pass? We passed as our actual parameter the number 3, which was a literal. Remember where literals reside? That was something that was in the constants pool, but it's a copy of that literal that got passed in and is now placed in the frame stack in the num1 parameter here in the frame for max, and similarly a copy of this literal which was placed as a 4. So there's a 3 in the constants pool, there's another 3 here in the frame. There's a 4 in the constants pool, there's another 4 here in the frame. And it executes, and it does its thing, and it returns, and the print comes out. And notice, remember, when it returned, frame got popped off the stack. We used to have num1 and num2, but now we don't. So at first, the frame stack was 1 level deep. Then the frame stack went up to 2 levels deep. And then the frame stack went back down to 1 level deep. Because when max terminated, the frame on the top of that stack got popped. So at this point, something's been printed out, and we're about to try to print something else out, but again, we need to make a call in order to resolve this expression, this whole thing that's going to wind up being a string expression that winds up getting passed as the argument to print line. By the way, if I was really going to be accurate about every single thing that's taking place, somewhere along the line, print line would go on the stack. And print line might itself be making other calls to other methods that go on the stack for all we know. I don't worry about that stuff. All I'm going to worry about is what's taking place in our own code. But if you really want to be accurate about what's going on in the stack, you've got to take into account the stuff that's not in our code that we're invoking from the API or from other libraries. There's a whole lot of stuff going on in the stack that we're not even looking at when we're looking at the debugger. We're only looking at what's going on in the stack from within our own code. So, once again, we have printed out this value as a result of calling max the first time, the first invocation of max, which was the integer version. Now we're about to invoke the one that takes 2 doubles, and there we have it. And we are at this point maybe here, and our breakpoint is right here, and we've got 2, once again, we have 2 frames on the stack. We have another num1 and another num2. Keep in mind that this num1 has absolutely nothing to do with this num1. There are 2 completely separate, independent things. And this one is a float, for example. So we have a num1 and a num2 in their frame, does its thing, gives back the result, prints out the result, and now we're about to, and again, the frame has popped off the stack. We're back in main now. Now we had just printed out the second line. And now we're about to print out that third line. Now watch what happens here. Here we're making a call to max, the max where we're passing 3 separate floats, doubles, I should say. That means it's going to be this version that gets invoked. And there it is. So a 3.0, a 5.4, and a 10.14. And basically the idea of this max is that it wants to return the biggest of all 3 of these numbers here, num1, num2, and num3. So what's it going to do? It's going to try to get the biggest of these 2 versus that one. Let me say that again. This method right here, which is going to try to get the biggest of these 3 values, is going to make use of this method right here to get the biggest of these 2 values, the num1 and the num2. And then when it gets that, it's going to compare that one against the num3. So first there's going to be an invocation of this. And there it is. In order to be able to call this max, we have to have resolved this inner max. And once again, I'd like to remind you something I've said before. When you see parentheses, you always know that what takes place inside the parentheses happens before what takes place outside the parentheses. And we're seeing that right here. So this method invocation is going to take place before that method invocation. So when we're here in this breakpoint right here, this has to do with this method invocation, with the 3.0 and the 5.4. That 3.0 and 5.4 is then going to give us back a result. And of course, the maximum of those two is 5.4. And then that 5.4 will wind up being compared with the 10.14 in a second call to max, to this max here. And then we went to 3 deep again, and then back to 2 deep again, and finally the print. So let's again take a look at the depth of the stack, how the stack grew and it shrunk, and it grew and it shrunk. Let's go back all the way to the beginning here. So here we have it. First we have main. Then we have the 1 max method. So we have 2 levels deep here. And then that got popped and we're down to 1 level deep. And then we're back up to 2 levels deep. And then we're back down to 1 level deep. And then we're back up to 2 levels deep again. And this brought us up to 3 levels deep. And then we came back down to 2 levels deep. And then we went back up to 3 levels deep. And back to 2 levels deep. And back to 1 level deep. And then we're done. So as you can see, during the execution of a program, that frame stack is growing and it's shrinking, and it's growing and it's shrinking, and it's growing and it's shrinking. Every time a method is invoked, its frame gets placed on top of the stack. And if that method invokes a second method, that frame gets placed on top of the stack. And every time a method terminates, its frame gets popped off the stack. So that the duration of the local variables of a method is only as long as the method is executed. Now, I'm not going to do this in the debugger myself, but I invite you to set some breakpoints in the code. I will just run it just to show you the results, the end results. So here it is. I'll just go ahead and run it, and we'll see what the output looks like. And there was the output. There are some other interesting examples from this chapter. Here's an example that has a method called GCD. And what GCD does is it takes 2 numbers and it returns the greatest common divisor of those 2 numbers. Nice little approach by that. It's got a loop that's basically got a variable right here, k. It keeps incrementing this k. And as long as k is less than both of these numbers, it's checking to see if k is divisible into both of those 2 numbers, and if it is, it's setting our greatest common divisor to be whatever k was. Otherwise, it would have just been 1. Let me just go ahead and run it. So let's see, two integers. Let's find the greatest common divisor between, say, 100 and, say, 40. And the greatest common divisor between 100 and 40 is 20. Go ahead, set your breakpoints here. Play around with it, see what it does. There's some other interesting examples here. Prime numbers. And also printing the calendar, which we'll look at a little bit in the next video. Not so much to really actually for running it, but to kind of get an understanding of top-down modular design. So lots of good examples of from Chapter 6 for you to look at on your own.